Hello, I am Saurabh Kumar Dutt, and here I welcome you to this lecture where we'll be studying today about trigonometrical identities. Now, in this lecture, we will be discussing about what trigonometry is, what identities are, what trigonometrical identities will be, what trigonometrical ratios are, who was the father of trigonometry. Then we have a sum which we'll be solving by the normal method, and then we'll also be looking up how to apply a special technique so that the sum can be solved in a very simple way. Now, all of this can be understood and kept in your mind so that you have other sums which come your way of the same type, then you're able to deal with it using these techniques. So make sure that you're here till the end of this lecture and absorb all of this knowledge and apply it to different sums. Right, so let's get started, children, and let's first understand what trigonometry is. Now, as you can see, trigonometry is actually made up of three words. The first is tri, which means three, gon, which in Greek means sides, and then we have metron, which means measurement, which in English is written like metri. So trigonometry is actually the study of the three sides of a triangle. So we can talk about a triangle to be, say, something like this. Let's say we name it to be some ABC. So this is the triangle which is ABC. Now, as you see here, there are three sides. First is AB, the second is AC, and the third is BC. Now, these sides are also written by the small letter of the vertices which are opposite to them. That means if we talk about the side AB, it will be written by small c. If we talk about the side AC, it will be written by small b, and the side BC is going to be written to be small a. This is the way by means of which you depict the different side lengths. So as such, this is A, this is small b, and this is small c. Next, now, children, when we have these sides, they are actually the intersection of two straight lines, right? So this is one straight line, this is another straight line, and when they intersect, then obviously there is some area space in between, right? There is some space of some area, and that is known as an angle. So there are three angles, right, along with the three sides. And just to study this, we have trigonometry. Isn't this very simple? No, actually it is not, because there are multiple other installations which have been done in trigonometry so as to make it complicated, and you will find that there are certain such sums which you will find to be really overwhelming, and you will not be able to deal with it just in one go, right? So there's a lot of technique, a lot of tact which is involved in doing sums of the higher order. But if suppose we go step by step, then I think understanding all the nuances, you'll be even able to do the complicated sums in a very simple way. Now, children, here first we now talked about trigonometry. So next, now I want to discuss about identities. Now, can anybody tell me what an identity is? This is a word which I have found in my teaching career of approximately 25 years that the children have very little knowledge of this. So can you throw some light on this? No? Well, I'll tell you. Whenever we talk about an identity, it is actually an equation which is always true, right? So whatever value of the variables you keep, it is always going to come out to be true. So if, say, we talk about an equation just like a minus b whole square, this is going to come to be a square plus b square minus 2ab. We know this by algebraic identities. That means whatever value of a and b we keep, this is always going to come to be true. And keeping the values of a and b to be 4 and 3, we can easily check it out, right? So here we will find that this will actually come to be one such where both the sides will have the same value. Like here we have 4 minus 3 on the left hand side, that will become equal to 1, and squaring it will become equal to 1. Further, we have a square, which is 4 square, that is 16, plus b square, which is 3 square, that is 9. 16 and 9 is 25, and from that is to be subtracted 4 3 is 12 is 24, and obviously that also comes equal to 1. So as such, whatever value of the variables you keep, this equation will always stand to be true. So whenever you have such sort of equations, they are then known as identities. So here I will write this, and I like you people to write along with me so that you can remember that for a long period of time. So please pick up your pen and write with me. An identity, and I like you to write identity in block letters, is an equation which is always true for all values of the variables. Right? So whatever value of the variable you'll keep, you'll always find that the equation comes out to be true. Just now we looked up this algebraic identity. Now similarly, we also have trigonometrical identities, but before we get to that, we should be knowing what trigonometrical ratios are. For that matter, children, there is one thing which has been done, is that a perpendicular has been dropped in, say, a triangle, or say there is a right angle triangle which has been formed. So let us now say that we have a right angle triangle to be, say, something like this, right? And now in this right angle triangle, this will help us in understanding the trigonometrical ratios. Now we'll make the closing side, which is something like this, right? And further now we have our right angle triangle made up. Okay, so after we have our right angle triangle, our next task obviously is to name it. So let's name it to be, say, some P, Q, R. Now, like I've already told you, you can easily name the different sides with the small letters of the opposite vertices. So PQ is going to become equal to how much? Small r. QR will become equal to how much? Small p. And PR will become equal to how much? Small q. That's good. So these are the three sides, and in between two sides are these angular points, right? Like angle QPR is actually angle P, because in this angular space there's just one angle, right? So as you can see here, we have a right angle triangle. So one of the vertices, like here we have it at Q, there is an angle of 90 degree which is housed. Now always remember that whenever you talk about the side which is opposite to 90 degree, that is the hypotenuse, right? Now, in accordance with the known or the unknown angle, we have the perpendicular. So if suppose we talk about angle R which is known, or angle R which has to be considered for some calculation, let us mark it to be, say, some angle theta, right? Or it can even remain to be R, right? The side which is in front of it will be known as the perpendicular, right? And the third side would automatically become the base, right? So now children, if we consider this angle P, right, I will rather do it in different colors so that you can understand it better. So if, say, now we talk about this angle P and say we mark it to be some phi, then the side which is in front of it is going to become equal to the perpendicular. As I told you, the side which is in front of the known or the unknown angle, or the angle which is being considered for some calculations, is the perpendicular. Now the side which is opposite to 90 degree will always remain to be the hypotenuse, even in the second case, right? And now the third side will be said to be the base. So this is the side which is still left out, and thus this will be known as the base, right? So this is how we have the different sides, right, and the different angles which are possible in a right angle triangle. For that matter, if you talk about here in this right angle triangle, you will say that there is one angle which is 90 and the sum of the other two which is also 90, because the sum of all the three angles should be equal to 180. That is, it should be supplementary. So if this angle Q is 90, then theta plus phi will become equal to 90 as well, right? So if you talk about this angle to be theta, then you can talk about the other angle to be 90 minus theta. Now children, next we have some trigonometrical identities which obviously will require some trigonometrical ratios. Now, what are trigonometrical ratios? Here we have trigonometrical ratios of sine of, say, some angle theta. Then we have the trigonometrical ratio of cos of angle theta. Then we have the trigonometrical ratio of tan of angle theta. Then we have the trigonometrical ratio of cot of angle theta. Then we have the trigonometrical ratio of sec of angle theta. And then we have the trigonometrical ratio of cosec of angle theta. Now, sine theta is perpendicular upon hypotenuse. So in accordance with the known or the unknown angle, we can easily find out the perpendicular and the hypotenuse and write this ratio. So this ratio is what, like I told you, it is the relation between the sides, that is the perpendicular and the hypotenuse, and the angle, right, of this triangle. So one is the angle, that is angle theta, which is angle R, and it has been related with the sides, that is the perpendicular and the hypotenuse, the perpendicular being PQ and the hypotenuse being PR. So can you see here, thus by trigonometric ratios we are able to relate the sides and the angles of a triangle, right? This is a very important facet of you doing trigonometry, as further when we talk about higher studies in trigonometry, all of this will be very much relational, and as such there will be more formulae which are going to be based on this. Now children, next after this, after we have SIN, so there is no sin which is committed, this is actually sine, SINE, which here is the abbreviation and the full form is SINE. Now next we have cos theta, which is the same as cosine theta, and that becomes equal to base upon hypotenuse. And the third is tan theta, which children is also sine theta divided by cos theta, right? And thus here if you try dividing, that will become equal to perpendicular upon base. Now next, cot theta is actually cotangent theta, tan theta is tangent theta, which is equal to the inverse of tan theta. As such, it can be written to be equal to 1 upon tan theta, and thus simply stated you can say that this is equal to what? This is actually your base upon perpendicular. And then we have sec theta, and sec theta will then become equal to what? It will become equal to 1, which is the inverse of cos theta, and that is hypotenuse upon base, right? And here, as I said, it is the inverse of cosine theta or cos theta. Now sec is actually secant theta. Then we have cosecant theta, which is cosec theta, which is actually the inverse of sine theta. So we have this to be 1 upon sine theta, and this becomes equal to hypotenuse upon perpendicular, right? So these are the 6 trigonometrical ratios, and as you can see here, first we have sine theta, and then we have the inverse of sine theta to be the last trigonometrical ratio. Then we have cosine theta, and we have the inverse of cosine theta, that is secant theta, to be second and second last. Then we talk about tan theta and cotangent theta, third and third last, which are the inverse of each other. So after you've learned who actually found out trigonometrical ratios, is what you should be knowing, right? After learning all of this, so who is the person who found out trigonometrical ratios? Can anybody tell me? Hipparchus. He was a Greek astronomer, mathematician, who was the person who found out trigonometrical ratios. And as trigonometrical ratios is the basis of all the trigonometry that you study, because without a relation between the sides and the angles of a triangle, the study of trigonometry will become something which is blank, right? As such, Hipparchus is said to be the father of trigonometry. There is no biological meaning to this, but obviously it shows that how much significance is given to this person who has found out this very essential term, very essential concept, which actually is all pervasive in this subject of trigonometry. Next, now children, after this we will be now talking about the trigonometrical identities. So when we talk about the trigonometrical identities, these are primarily 4 in number. So these are trigonometrical identities, and like you have already seen, this is going to be always equal from either side of the equation, right? So the first, children, is the one that we've just studied. That is, if you talk about tan theta, then tan theta is given to be equal to sine theta, which is divided by cos theta. So if you just keep the value of sine theta and divide it by the value of cos theta, you will get to tan theta, right? Further after this, children, the first important square trigonometrical identity, that is, if you talk about sine squared theta, to which if you add cos squared theta, then that comes equal to 1, right? So for whichever value of theta you look up, you'll always find that this will come out to be true, and that is why this is known as a trigonometrical identity. Next, children, after this we have sec squared theta minus tan squared theta, which is equal to 1, and very easily you can remember this as s comes first in the order of alphabets, and after that comes t. So from the one which has come first, you subtracted the one which has come later to get to 1, right? Just a way to learn it, right? A mnemonic. Next, after this we have cosec squared theta minus cot squared theta, which is equal to 1. Again, if you try to remember this, you can do it this way, that from the one which has got more alphabets, you subtract the one which has got less number of alphabets to be able to get to 1, right? So as such, here we have all of these three trigonometrical identities which are all dealing with the square of the trigonometrical ratios. As such, they are also known as square trigonometrical ratios, square trigonometrical identities, right, which are very much in use to prove other trigonometrical identities, right? So all of this that I have just discussed is what I'll rediscuss so that all of this is very well understood. The first thing that we discussed was that when we talk about trigonometrical identities, we are primarily interested about what trigonometry is. That is, it is the study of any rectilinear figure which has three sides, right? And its study is trigonometry. Now, in it, thus, we will be not just studying the three sides, but we'll also be talking about the three angles which are associated with these sides, as the intersection of any two straight lines will give an angular space which is an angle, right? Now, we also talked about how opposite to the angular spaces, we can be writing the sides to be written by the small letters. So as such, opposite to angle A is side small a, opposite to angle B is side small b, and so on. Now, whenever we talk about identities, you have to remember that these are those equations which are true for any value of the variable. For that matter, if say we talk about an equation which say is something like this, that is x plus y is equal to 16 and x y is equal to 64, right? So here you find that this will come out to be true for a specific value of x and y. That is, if we keep the value of x to be 8, right, and if we also keep the value of y to be 8, so we know that 8 plus 8 will become equal to 16, and again if we multiply 8 with 8, xy actually means x into y, right? So 8 into 8 will become equal to 64. So this is true for just one value of x, and that is 8. For other values, this will not come out to be true, right? So thus this is not an identity, because an identity is such an equation which is true for all the values of the variable. So next, after understanding what trigonometrical identities can be, now we'll first understand what trigonometrical ratios are. For that matter, if we talk about the person who invented trigonometrical ratios, he was Hipparchus, right? So here thus we have the first to be sine theta. The abbreviation of SINE is actually SIN, right? And it's perpendicular upon hypotenuse. For that, first you should be having a right angle triangle, and the side which is in front of 90 is your hypotenuse. The side which is known or unknown, right? That is this angle which is known or unknown. The side which is in front of it will be known as the perpendicular, and the third side will be known as the base, right? So here thus, if we talk about sine of angle theta, then that will become equal to this perpendicular, which will be PQ, divided by the hypotenuse, which is PR. So if you're required to write for this specific right angle triangle, whatever be the three sides of this triangle, right, then you'll keep the values and get to sine theta. Next, cosine theta or cos theta is given by base upon hypotenuse. tan theta or tangent theta is given by sine theta upon cos theta, which is actually perpendicular upon base, which you'll get to see if you divide this equation by this equation. Next, children, we have cot theta, which is actually the inverse of tan theta, and thus it is base upon perpendicular. Next, we have sec theta, which is the inverse of cos theta, and that is hypotenuse upon base. Right. Next, we have cosec theta, which is the inverse of sine theta, and it is hypotenuse upon perpendicular. So these are the trigonometrical ratios which relate the sides with the angles of a triangle. Now this is something which is remarkable, as without the trigonometrical ratios you will hardly be able to tread even 1 feet. Right. That means trigonometry is all based on trigonometrical ratios. As such, the person who found it, Hipparchus, is considered to be the father of this branch of mathematics, which is trigonometry. Now, children, after this, we also discussed about the trigonometrical identities. The first is, if we talk about tan theta, that can be written to be equal to sine theta upon cos theta. Right. This obviously is also going to be true for any value of theta. Next, we have the first one, that is sine square theta plus cos square theta is equal to 1. You can remember it this way, that in the Supreme Court everybody is 1. Right. Just a mnemonic. You can think any other mnemonic that you feel like. Next is sec square theta minus tan square theta is equal to 1. Here, as in the order of alphabets in English language, A, B, C, D, you find that S comes first, and then after that comes T. So as such, sec square theta minus tan square theta can be said to be 1. Next, we have cosec square theta minus cot square theta to be equal to 1, which is another trigonometrical identity. And you can remember it this way, that from that trigonometrical ratio, except cos, which has got more number of alphabets, if you subtract the other trigonometrical ratio with C, except cos, right, you will get to see that it'll come to 1. So from the one which has got more number of alphabets, you're subtracting the one which has got less number of alphabets, such that both of these trigonometrical ratios are starting with C and are not cos. Right, and their difference is equal to 1. So this is how, children, you can learn all of these trigonometrical identities. Now after this, after all of this knowledge accumulation, now we should try and do a sum. And initially, children, I'll be giving you people a little time for trial, and then you will be expected to look up what the teacher is teaching, right, and then you will be able to understand everything, right. So as such, next, now what we do is we will now be talking about here this sum. Like I told you, I'm going to give you people a little time for trial, right, and after that I'll be discussing the sum with you people. You can obviously pause this and try it for a longer duration of time, but here I can't give you infinite time, isn't it? Few things more: when you're to study, make sure that you're seated at a place such that there is no disturbance there, and you don't disturb yourself by picking up the mobile, the laptop, or probably iPods or whatever, right? Just make sure that you're seated on a table and chair and focus exactly where the teacher's pointer is, and then you'll be able to understand the maths. And for that matter, I have made a first video as to how you should study maths, for that matter also how you should study maths, in my channel, right, so that you can get the best out of it. Now here we are trying to do one sum, that is to prove the trigonometrical identity which has been given to us here, right. Now if you try and solve this like a layman, that means a person who is not very much say a specialist in trigonometrical identities, right, the person is going to do what? We'll see that there is sec, tan, cos, right? So as such, he will convert all the trigonometrical ratios in terms of sine and cos. And now in the next step, thus, this is going to become something like this. That is, we will now have here this trigonometrical identities left hand side, which can now be written as 1, which is divided by sec A, which can be written as 1 upon cos A, right, and from that is subtracted tan A, which can be written as sine A, which is divided by cos A, right, and further from that is subtracted 1 upon cos A, right. Next, now children, as in the first term we have fractions, so our task is going to be to take an LCM, right? And as such, this is going to become equal to cos A, which is the common LCM, right, the common denominator, and in the numerator, as both the denominators are exactly the same, so in the numerator we will have it to be 1 minus sine A. Now here, children, I'd like to tell you one thing, that if suppose you have something like A upon B, which is divided by C upon D, then that becomes equal to A upon B, right? This division sign of the whole denominator can be written as the normal division sign, C upon D, and then as you do it in BODMAS, you will now write A upon B, the first fraction, convert the division sign to multiplication sign, and then you will write the reciprocal of the fraction which has come after it, that is D upon C, right? So here, two children, we are going to do this as such. Now we will have 1, which is actually the numerator, which is divided by, that means this is the whole denominator sign, right, by 1 minus sine A upon cos A. So as such, cos A will come over to the numerator, and thus this denominator is going to be 1 minus sine A, right? Just try and visualize. This is just like A upon B, which is divided by C upon D. So this will become A upon B into D upon C, that is cos A upon 1 minus sine A, right? Now from this is subtracted 1 upon cos A, right? And then further here, what we can do is we also now talk about taking an LCM, and when we take an LCM here, this is going to become equal to how much? This will be the product of both the terms, that is cos A times of 1 minus sine A, right? So further here, children, next what you do is here, after taking an LCM, now you will have the first term getting multiplied with the denominator or the other fraction, which will make it cos square A, and in the numerator of the other fraction you will now have this cos A, right, which will divide cos A times of 1 minus sine A, the LCM, to give you 1 minus sine A. As such, you will have minus times of 1 minus sine A, right? Now further, children, what will happen is you will now have here this minus sign getting multiplied inside, right? Or rather, you can do one thing more. You can write this cos square A as 1 minus sine square A, right? Do remember that we have this formula that sine square theta plus cos square theta is equal to 1. As such, if you talk about 1 minus sine square theta, children, then that becomes equal to cos square theta. So as such here, 1 minus sine square A can now be written as cos square A, right? That is this, and we've replaced this value, and after this then we have minus times of 1 minus sine A, right? And then further in the denominator we have cos A times of 1 minus sine A. Now here, children, we find one thing, that if you talk about the first term, it is actually 1 square minus sine square A, and this obviously is something like A square minus B square, and by algebraic identities we know that this is A minus B times of A plus B. As such, now we keep the value, and we now have 1 minus sine A, which is going to be multiplied with 1 plus sine A, just like A plus B. And then we find that 1 minus sine A is also there in the second term. As such, this 1 minus sine A in the next step is going to be taken common outside. And in the denominator, children, you will have now cos A, which is going to be multiplied with 1 minus sine A. And you find this 1 minus sine A can now be taken common outside. As such, here you will now have here 1 minus sine A, which is going to be taken common outside, and then inside, children, you'll be left out with 1 plus sine A, right, from which 1 is subtracted, as 1 minus sine A has already gone outside. Now in the denominator, children, you have cos A, which is multiplied with 1 minus sine A, and as it is multiplied with cos A, so both of these terms are now going to get cancelled. That is 1 minus sin A will get cancelled from the numerator and from the denominator, and plus 1 minus 1 will also get cancelled. As such, now you will just be left out with sin A in the numerator, and in the denominator you'll be left out with cos A. Right, so this is what is going to be left out, right? And now children, we will move over to the right hand side. So if we talk about the right hand side, the right hand side is actually what? The right hand side is 1 upon cos A minus 1 upon sec A plus tan A. So we have 1 upon cos A, right? And to that is subtracted, if I remembered correctly, 1 upon sec A plus tan A. 1 upon sec A plus tan A. The lines are becoming crooked. So this is sec A plus tan A, right? So here children, next what you can do is, if you talk about this here again, you can convert all the terms in terms of sine and cos. So on the left hand side you have a 1 upon cos A, which will remain to be as it is, and in the second term we will now have some changes, as this is going to become equal to 1 upon cos A, right, to which is going to be added sine A upon cos A, right? So for the children, next, as we have fractions, so our task is to take an LCM. So this will become minus 1 upon, and on the denominator we have cos A, which will become the common denominator, and here we'll have 1 plus sine A, which will come over to the numerator, and this has been subtracted from 1 upon cos A that we will retain. In the next step children, as we have again one fraction which is divided by another fraction, so we will write this as 1 fraction divided sine by the second fraction, and as such it will become 1 fraction A upon B into reciprocal of this fraction, which will thus become cos A upon 1 plus sine A, right? So as such we will have 1 upon cos A, right, and minus we will have cos A, which is going to be divided by 1 plus sine A, right? So here children, next what we do is, as we find that both of these denominators cos A and 1 plus sine A are different, as such the LCM is going to be the product of both of these, that is cos A times of 1 plus sine A is going to be written here. And next here children, we will now have cos A dividing this LCM, which will give you 1 plus sine A. As such 1 plus sine A will come over here, and then further from it is going to be subtracted the product of cos A with what? With cos A, as when 1 plus sine A divides this LCM, you'll be left out with cos A. So as such we will have minus cos square A, that is cos A into cos A, right? So now children, in the next step we can write this as 1 plus sine A, and again this cos square A can be written as 1 minus sine square A, as we wrote it above. Remember, we had sine square theta plus cos square theta to be equal to 1. As such, if you talk about cos square theta, if we talk about sine square theta, then sine square theta can be written to be equal to 1 minus cos square theta, right? So this is what we are going to replace. As such, next now what we will do is, we will now have here 1 minus sine A times of 1 plus sine A to be written in place of 1 minus sine square A. So we'll have cos A, which is multiplied with 1 plus sine A, right? And then further we have 1 plus sine A, right? And from which is subtracted. Now we can write it again as A plus B times A minus B, that is 1 minus sine A times of 1 plus sine A, right? And in the denominator children, we have the same entirety, that is cos A, which is multiplied with 1 plus sine A. Now children, in the terms that we have in the numerator, we find that we have 1 plus sine a, which can be taken common outside. As such, when we take this 1 plus sine a common outside, then we are left out with what? We are left out with 1, and then further minus times of, we have 1 minus sine a, right? Because 1 plus sine a has already gone outside, and you're just left out with 1 minus sine a. Now in the denominator children, you have here cos a, which is multiplied with 1 plus sine a, and as such here you will find that 1 plus sine a being common to the numerator and to the denominator, both in multiplication, so it will get cancelled. Similarly, in the next step, what we can do is we can even cancel off the ones that we do, like we did in the last step, that is the left hand side. So we have 1 minus 1 on multiplying the minus sign inside, and we have minus minus plus sine a. That is all that is left out in the numerator, and in the denominator we are left out with cos a. So for the children, what will happen is you will find that both of these ones will get cancelled, right? That is plus 1 and minus 1, as both of them are additive inverse of each other. And next you will just be left out with sine a upon cos a, right? And that is just the same as with what you were left out in the left hand side, remember, right? Sine a upon cos a. And as such, you can say that therefore you have the left hand side which has come equal to the right hand side, and thus this stands to be proved, right? So children, all of this I will just quickly discuss once more. In the question, you've been given here that you have 1 upon sec a minus tan a, right, minus 1 upon cos a, which is equal to 1 upon cos a minus 1 upon sec a plus tan a, right? Remember children, a few things, right? When I am to give the second explanation, then too don't pick up your writing material and keep the focus intact in a similar way, sitting straight on a table and chair, so you'll be then able to understand everything, right? When there are certain concepts which are with different colored inks on the side of the margin, make sure you write them in a separate place as formulae or concepts, and also learn them up, because in times to come they are going to get applied even in other sums, right? Okay, so one thing more, do remember that this is that solution of the sum which a normal person will do. That means a person who does not have much of practice of trigonometry, or does not know much of techniques which can be applied to trigonometry to make it very simple, right? In times to come, I'll be giving you the second solution, which is the simpler solution by applying the technique. But for that, you will have to click a link which is there on the description, right? Just at the beginning of the description you'll find it, and then when you get to it, then you will get the simpler solution, right? Then you will go to Substack, right, and do subscribe to me there, so that you can get more of data. You will find that there is a lot of data which I've kept in Substack for your consultation, for your study, so that you can make your mathematics very strong, right? So make sure you go to Substack and subscribe, right? And then you will get quite a lot of matter which pertains either in this class or probably in a higher class, or something that you might have studied in an earlier class which you did not know well. So all of that can be done from this app, right? You just require to click on the link which is there at the top of the description. Now if you have any other doubt, make sure to fill up a form which is there again in my bio, right? The problem resolution form, where when you fill up your particulars, right, I'll get back to you and I'll make sure that your problem is solved for life, right? Okay, so now children, next what we do is we're talking about the left hand side here, and in the left hand side we have 1 upon sec a minus tan a minus 1 upon cos a. So here what we do is, if we talk about the denominator, this can be written in terms of sine and cos, that is 1 upon cos a, and tan a can be written as sine a upon cos a, right? In the next step, we just take an LCM of both of these fractions. As such, that then becomes equal to cos a, which is the common denominator, and in the numerator we'll have 1 minus sine a, and from this is subtracted 1 upon cos a, which we will keep copied as it is. Now further here, what we have is we have now reciprocated this fraction, as this is 1 divided by this fraction, or 1 into reciprocal of this fraction. As such, cos A upon 1 minus sin A, and further minus 1 upon cos A is as it is. Now next, children, what we do is when we take an LCM here of both the fractions, we'll have cos A times 1 minus sin A, and then we will get cos A getting multiplied with cos A to give us cos square A, and 1 minus sin A getting multiplied with 1 to give us minus times of 1 minus sin A. Always remember that these signs are very important, right? And whenever you have a minus sign, the terms which are to come after it, which is multiplied with that minus sign, make sure to put up a bracket, otherwise you'll make a mistake as to what is positive and what will become negative, right? Now next, children, after this we now see that cos square A can actually be written as 1 minus sine square A, because we have sine square theta plus cos square theta to be equal to 1, right? As such, now we write it to be 1 minus sine A times of 1 plus sine A, as we know that A square, that is 1 square, minus sine square theta, that is B square, is A minus B times of A plus B. So as such, we have 1 minus sine A times of 1 plus sine A, right? And minus 1 minus sine A. Now next, what we do is, if we take this 1 minus sine A common outside, we will now here left out with 1 plus sine A minus 1. Now we find that this plus 1 and minus 1 will get cancelled, and you'll be divided by cos A times of 1 minus sine A. Now this 1 minus sine A will get cancelled from the numerator and from the denominator, and then you will just be left out with sine A upon cos A. So this is the most simplified expression which is possible from the left hand side. Now on the right hand side, children, you have a 1 upon cos A minus 1 upon sec A plus tan A. So what you do is, here you can again convert the sec and the tan in terms of ratios which are of sin and cos. So sec A becomes equal to 1 upon cos A, and tan A becomes equal to sin A upon cos A. Now when you take an LCM here, you will have the LCM to be the common denominator, that is cos A, and in the numerator you just have to add the numerators to get 1 plus sin A, because the denominators were exactly the same. Now next, as this is divided by this fraction, so this can be written as this into reciprocal of this fraction, so this will become cos A upon 1 plus sin A. Alright, next, now we find that if you have both of these terms, they are fractions, so as such you'll have to take an LCM, and when you take an LCM, this will become cos A times of 1 plus sin A. Thus 1 will be multiplied with 1 plus sin A, and cos A will be multiplied with cos A to give you cos square A. Now this cos square A, as we know that sine square A plus cos square A will become equal to 1, so here we'll thus have this cos square A, which can be written to be equal to 1 minus sine square A, right? So here thus what we do next is we can now again write this to be 1 minus sine A times 1 plus sine A, as we know that A square minus B square is equal to A plus B times of A minus B, right? So we now apply this. As such, here we have 1 minus sine A times 1 plus sine A. Now 1 plus sine A is common in both of these terms. We take it common outside and cancel it off with 1 plus sine A that is there in the denominator. Now we are left out with 1, as 1 plus sine A has gone outside, minus times of 1 minus sine A, and further here what will happen is you will get to see that minus, when it will get multiplied with the 1 inside, it will become minus 1. So 1 minus 1 will get cancelled, and thus you will just be left out with sine A in the numerator, and in the denominator you will be left out with cos A, right? So sine A upon cos A is what you will get, and sine A upon cos A is what you even got if you talk about the left hand side, and thus we can say that the left hand side matches to the right hand side, and thus this stands to be proved. Now, as you know, I'm going to do the sum again, but now by a very simple method. But for that, you got to do something which is very simple. That is, you just got to click on the link which will be there at the top of the description. For that matter, for your ease, I'll also give it as a pinned comment, the first comment that you'll get in this lecture, right? In the first comment, right, you'll find that it is again a Substack link to which you can click and you can get there and look up the other part of the solution. There you will find other sums and other concepts also which are very much of your use. Do subscribe, and whenever you have a problem, make sure that you put up an email to me at themathematicshelpline@gmail.com. For that matter, there's another link which is there in my bio, a webinar link, right? So just fill in few particulars and come to my webinar, where not just will I be teaching you certain things which are there in mathematics, but I'll take you in a journey from being something in mathematics to becoming really somebody big in mathematics, and which will be a journey actually from education to employment. So I have big plans for you. So when you get in touch, I will let you know about all of those plans, and I will make you rise and become the best person in capability, in academics, and in qualifications that is possible. And for that, there is much more which is to be shared. So just do get in contact, right? And there is much to be done. Moreover, when all of this is done under my purview, under my guidance, just you seated before me, right? Probably not here where I am, but anywhere else. But even then, there can be a lot of impact which can be transferred, which can bring results. So make sure you take use of this, right? And make yourself to be a very good specimen of what you presently are. Bye, children. Have a nice time. Bye.